Hey everyone, thanks for the good feedback on my last video about the pendant. You know, just like the pendant, the Toolchanger was was really difficult to just figure out how to get started and how to do. And you know, I mentioned in the other videos, there's been so much great documentation about LinuxCNC, but kind of the basic stuff is just not there. At least it hasn't been there for me, and I'm a technical guy too. So anyway, I wanted to spend a couple of minutes to talk about how I got my Toolchanger going, and there's some really good code that helps you, again, in the sample files. If you haven't seen my Linux CNC for Dummies, check that out. But I just wanted to go over a little bit of the basics on how I was able to talk to my Toolchanger. So this is my initialization file. I'm using PPMC hardware. A lot of people use Mesa, but I suspect it's close to the same. So this is essentially my ini file. And there's a section here that, you know, and who the heck knows why this is named this, but it's the RS274NGC section right here. And this is what, where you can remap an M6 command. So an M6 is, you know, select a tool command. And essentially it happens right here, remap M6. I don't know what mobile group 6 is, but there's a change prologue to start, and then there's the actual NGC, the actual logic to do it is called tool change, and then there's an epilogue. I think I had to do something for both the prologue and epilogue. I don't remember. But I really want to talk about this tool change, because within this is kind of the secret about how you interact with hardware within the program. So we define essentially a new M6 command, a new tool change command. And then if you'll notice down here in the how file sections, we load this file called toolchange_binary.how, right? And that file is what teaches your software, your LinuxCNC, how to talk to your specific hardware. So let's look at this file. Because it's all text files. So there's a couple of things here. I'll talk about Carousel in a second. Carousel is a software that I think a guy named Andy Pug wrote, and it's super helpful. It'll actually handle a lot of different kinds of Toolchanger carousels, more than just mine. But ultimately, I use Carousel, and then I use this file to define stuff. So let's go over it. So first things first is you have this load RT carousel, and Carousel is a program, like say I think this guy Andy Pug wrote. And Andy, if you're out there, thank you very much for doing it. It was good to me. Ultimately, after I figured it out, I have 20 position tool changer, so you can see pockets equal 20. And then I have there's a binary encoder, and what it is I think there's 5 little pins, and there's actually a metal thing that goes underneath the pin, and you know, when the metal thing passes underneath it, it goes high, and you can see it, right? So there's actually a, you know, kind of a, you know, like a literally metal binary encoder for the tool changer, and we had a servo thread for the carousel. I never really have understood this. I just used an example that I found. So okay, now we actually get into the business of adding things that are real in hardware so that the software knows about them, right? So I use these net commands, and I use these bits 0 through 4, 5 bits. And I basically say that the carousel number 0, since bit 0, since bit 1, since bit 2, 3, 4, are mapped to an input from my PPNC hardware, right? So if you had Mesa, this would be your Mesa hardware. So basically I said that this PPNC 0 DN number 16, which is just simply a binary input, that is carousel bit 0, and then 17 is 1, 18 is 2, 19 is 3, 20 is 4, right? And now what I've done is I've made it so that Carousel can understand when each one of these physical wires is high, right? And I think I had to do in not because it was the opposite. You have to figure it out the hard way. So that is the number one thing to figure out, is that the way you get an input or an output in your hardware to talk to the software is through these net commands. And then there's a strobe bit, and I call this a strobe bit. Ultimately, it's essentially every time the tool changer goes over you know, an actual slot in the tool changer, this pin number 21 goes high, right? So I call that the carousel 0 strobe. And that's critical. That way you basically know what the lights are. And then of course when I was testing it, I would go and I would put those 5 pins up on the scope, and as the tool changer went by, I'd actually be able to read them. And I can show you that a little bit later. So then the next thing we need to do is define our digital inputs and outputs. And I don't know why this was so hard. Just like everything in LinuxCNC, once you figure it out, you're like knocking your head how easy it was. So there are these two commands, M64 and 65. Actually, 3 commands. M64 and 65 are outputs, and M66 is an input. And so let's look really quick at that in the LinuxCNC reference. So if I look at the M62 to M65 command, this is essentially, if you tell it M64 or 65, you tell it turn on a digital output, right? M65 is turn off a digital output. That's it. Pin goes high, pin goes low, nothing to it, right? That's it, right? So just, M64, M65, and then M66 is a wait on an input, right? So you can wait on some particular input, and you can tell it, do it right away. Don't wait for it to rise, wait for it to fall, wait for it to go high, wait for it to go low, right? So there's, and you can do some waiting. So basically, in this case, it would be M66 is wait on input number 0. L3 is wait for it to go high, and wait up to 5 seconds. That's the Q5, right? So when you actually want to talk to your hardware, the way you do it is you say M64, M65, but it has to know what M64 and what M65 to talk to. So I defined all these things, right? So I have carousel enable this is an output. So I want to there's basically a line that you need to light high, and this is a virtual line, by the way, to tell it to enable the carousel to actually move. And then I've got these physical outputs, right? So one of them is retract. In my case, everything's hydraulic, right? So it drives a hydraulic relay. But this is retract the carousel arm. This is extend the carousel arm. This is hit the tool release, right? And each one of these you can see goes to a physical output of my PPNC hardware. So physical output 06 is the retract arm. I've got a carousel unlock. I've got a carousel lock. I've got spindle orient, arm, and then there's 2 speeds for the arm going in. So I've got arm slow. I've got jog forward. I've got an air blast. I've got carousel go slow. I've got this rotate slow. I've got carousel rotate forward, carousel rotate reversed. And then also I've got, for the spindle speed, I've got a shift to high and shift to low. And so you can see each one of these, I connect to either a motion pin, right? Or a carousel pin. And then that pin connects to some physical output, right? And the same thing, input, I've got carousel, there's a carousel ready input. And again, that is that's a virtual pin. I've got a little, there's a little switch that tells me if the arm's retracted, right? So that's an input that's, PPMC DN13, and the not, I think because it's opposite. I've also got a signal if the arm is extended, right? That's pin 14. I've got pin if the tool is released, that's pin 24. If the carousel's unlocked, if the carousel's locked, if the spindle's oriented, if there's a tool in the carousel, if Z is homed, et cetera, et cetera, et cetera. So the way that you do all this is you tell it, here's my physical pin, right? And then I'm gonna net that to one of these other either motion commands or carousel commands, right? And then of course there's this carousel section, which I think Andy wrote. I didn't really understand it, but it's essentially we're creating some signal that tells us what carousel pocket is there, right? So you have to get this right, and this is how you connect the actual hardware to your actual software. All right. Well, then what happens after that, right? So let's look at 2 bits. One is let's look at Carousel. So Carousel is this, it's essentially a program that you can just use, right? And you do a load RT tool change, and just remember before there's the number of pockets was 20 and what kind of encoding and how many there were, etc. And then essentially what you do is you just you define these pins. So remember we defined these pins before. In fact, let me actually show you some. So let's see. So carousel ready, carousel 0 ready is right here. Let me highlight it. I don't think the mouse shows up too well in the video. So carousel 0 is ready, right? And then here it is right there, carousel N, which means 0. You can have more than one carousel in this program. Carousel 0 is ready. This pin goes high when the carousel is in position, right? So essentially, whenever the carousel thinks it's ready in position, carousel tells us that's that, right? And then you can do essentially cool stuff, right? You can tell it to go to a certain number, and then it'll do it, and then it'll tell you when it's done. So, and ultimately what you have to do is you have to enable the carousel, you have to tell it to go somewhere, and then it actually moves and does that. So Carousel is super helpful in just figuring out the logic of, you've got these essentially, bits that go high and low depending on what position it's in. Carousel manages that. I actually had a little trouble with that in that it didn't quite stop right for me and still doesn't. And there's not a lot of adjustability in and out. And I was able to figure it out. I ultimately, it worked out, but there's a little adjustability as far as going forward and backward that would have been helpful. But otherwise, just what a terrific program, right? So this is one bit, and then the other bit is you actually have to write your own little program, right? And so let me actually show you the program itself that I wrote. So I did this at first. I just made myself a slide that does the logic, right? So let me walk you through it really quickly. When I do a M6 command, tool X, tool whatever, right? By the way, I have a lot of safeties in here, and I screwed up almost every way you could think of. It really is important to put a bunch of essentially safety features in your code, because you just don't know what conditions it's going to be in when the M command comes in, and it needs to know, right? So the first thing I do is I ask myself, is the Z-axis homed? Because if it's not homed, then when I lift the big the big spindle up, it might not go in the right place, right? So it could crash. So that's one. And then I tell it to make the arm and the rotate go on slow. And then I orient the spindle, and then I check if the spindle is oriented, right? Then I move the whole head up all the way up to the high Z position, I call it, which is the position where you would load in and out of the carousel. And then I ask, is the tool in some position greater than 0, right? And if the answer is yes, then I check what carousel tool it is, and if not, I tell it to move. I tell it to move to 0. And then ultimately, I have this little flow chart of how this works, right? So I move Z to the low one, I extend the arm, I check and make sure that the arm extend is true and the arm retract is false, right? I do a tool unclamp, I check to make sure that the unclamp is true and the clamp is false, because I have a sensor for each. I tell the arm to stop extending, right? And now, so now the Toolchanger is essentially engaged with the tool, and it's unlocked. And then I tell the Z to move up, right? Move Z to the high Z position, right? And now I've got essentially the Toolchanger, or the Z has pulled the tool out, has pulled itself away, and you just have a Toolchanger. I tell the carousel to move to whatever tool I want, right? And then I extend the arm, I check and make sure it's true. I turn the tool unclamp off, I check, etc. And so you go around, and ultimately I've got this, this algorithm that tells me, that assures me that I've unloaded a tool and I've loaded it into the right bit, right? And I've got these, these commands, right? Yeah, I can unlock the carousel, I can check, I can turn it off, etc. So I just made a little bit of a program, and then of course you have to program the program. And that is what you call an O subroutine. And again, I don't know what language this is in. Is it Python? I don't know. But remember the toolchange.binary. This is my program, right? And I really wrote this somewhat in ignorance. I looked at the examples and did my best to figure out what to do, and I did some trial and error, and ultimately it worked out. So the first thing that I want you to notice is that it's really just a bunch of M something commands. M66, M64, 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 M66, etc. And then I've got a bunch of error codes. So let's just go through a couple of these. So remember, from my flow chart, the first thing I wanted to do was to make sure that the Z-axis was homed. That way I know that I'm moving the Z-axis in the right place. So I say M66, P8, L3, Q3. Right? M66, P8, L3, Q3. Now let's go back over to my binary and look at where the M66 P8 is, right? So M66 is the digital input, and it's number 8. Now, oh my gosh, what a pain in the neck to figure this out, but here it is. So motion digital in 08, right, is Z homed. thing, right? So an M66 will read motion.digital-in-08, right? M66P7 will go to number 7. I'll show you that in a second one. So ultimately, when I say check this motion digital in number 8, because it's netted here, it goes to HAL UI joint 2, is it homed or not, right? Yes or no. And if it's homed, yes, it gives you a 1. If it's homed 0, not, it gives you a 0. That's the trick, right? It doesn't even sound simple now that I explained it, but it's pretty straightforward, right? So let's go back and look. So I said M66, read something, read number 8, which I just showed you where number 8 is, and then I think it's read if it's high, and then wait 3 seconds, wait up to 3 seconds for that, right? And then if the answer, and I don't know why number sign or pound sign 5399 is the answer, but that's the answer. If the answer is less than 0, right, then it's not homed, right? And then I do essentially a little, this is a message that shows up on the screen. And why does that show up on the screen? I don't know. And by the way, why is there line number? I never really did figure out the line numbers. I just kind of copied it and messed around until I got it to work. I would love like a basic how the heck does this work tutorial. Very helpful. But anyway, this checks. So this line checks to make sure Z is homed. If it's not homed, it exits the subroutine and puts this little error up on the screen. So then what do we do next? So M64P7 and M64P10, and we know already from my flowchart that is, I just checked if it's homed. Now I know that I want to turn the arm and the rotate to slow because they have 2 speeds and the fast speed's pretty fast. So I want to activate number 7 and number 10. So let's go back to our tool change binary and find the M64. Let's find number 7 and number 10. So here's number 7. Right, and ultimately that is an output PBMC number 8, but it's the arm slow output, right? And I know that, right? And number 10 is the carousel slow output. So the motion.digital-out-10 is the P10 for an M64 or M65, just like the M66 is numbered the way. It took me a while to figure it out, but once you figure it out, you can do kind of complicated, cool stuff. So, all right, then let's do the next thing, M64P6, that's orient the spindle. So guess what? We're going to go over and we're going to look, and number 6 is going to be the spindle orient pin, and let's find it. There it is, spindle orient, right? So spindle orient, that's D out number 18 in my PPMC system. It'll be different for you, but you get the idea is that this number 6, this digital out number 6 for motion is whatever thing you want it to be for spindle orient. Anyway, that's it, right? So it just keeps going. I can go over a couple others, and I will just to show you. But this M64, M65, M66, these are the key. This is the key to actually moving hardware and reading things from hardware is to do the M66. So let's look at just a couple of them, right? So the next, I'm going to skip these because I had actually a problem with my orient. Spindle orient going high, and so I checked 3 other things just to make sure. But let's look at something else, right? Let's look at, all right. So once I've decided that my Z is homed, and I've got and I've slowed down the all the bits. Then what I do is I say, all right, I want to move the Z axis to the high load position, right? So that's G53. Let's find G53. Hold on just 1 second. So let's go over to the G codes. Oops, that's the M codes. Hold on. So here's G53 coming right up. It's around there somewhere. There it is. Move in machine coordinates. Now, it's very important to use machine coordinates because I don't want some other coordinate system to be enabled and then move it to the wrong space. Because again, you're moving around a lot of metal. You want to make sure that the mill's going where you want, right? So ultimately, G53 is move machine coordinate system, and then I move it to some Z position. So let's go back and look at that. Sure enough, Z is 1.78. I move it to 1.78. Okay, and then I look and see if there's a tool in the spindle. Right, and And so then I've got this if statement, right? So this is O100. Again, I don't know how the numbering works, frankly. I just made it up. So I say if the number tool and spindle is not equal to the current pocket, but these come from Carousel, by the way. Then I gotta tell it to die, right? So that's number one. Number one, it'll give me essentially an error. And then what I do is I do another G53. We just went over that. So I move the head down to the low position, and then I extend the Toolchanger arm, right? So M64P2. So let's just do one more here. M64P2. This means this is going to be an output, M64, and it's going to be output number 2. So let's go over here and find output number 2. Well, there it is. It's the arm extend, right? So just exactly like that. So anyway, I'll stop there. You get it. You can do a wait. G4P3's wait 3 seconds. And then you can see I've got a whole combination of M66 commands and 64s and 65s and 53, stuff like that. And it just ultimately moves the Toolchanger. And if you look at some of my other videos, you can actually see a video of the whole changer working. But that's it, right? So, just to kind of recap really shortly, in your ini file, you define a HAL file with your definitions. And you define this this funny RS274 NGC remap right here, and you tell it to go to this file to actually do your M6 remap in this case. I also did a remap of the S for the speed because I have a 2-speed spindle, and I'll do a video on that too. But same. It's actually the same idea, but way more simple. So you just tell it to go to tool change when you want to do an M6, and then if you look at tool change, you can see I have my logic, which I've kind of clumsily written. I'm sure a good coder would have done a much better job. One thing that's really important is I put a different error code in every case, and that was really helpful in debugging because when something went wrong, it would tell me carousel was didn't extend, carousel was still retracted, tool didn't release, etc. Right, and that really helped. And I've got this relatively long program, at least for my skills, to make this whole thing go. And then at the end of the day, you end the subroutine and it's over. So that's it, right? You've got this binary that defines the bits that equal the physical bits that equal the carousel input, so you can spin the carousel around. And thanks again, Andy Pug. And then you've got these M64 and M65s that are essentially inputs and outputs for your physical hardware. And then, when you have these, then all of a sudden you do M64 and M65 and M66P whatever, and you actually toggle that pin or read from that pin. So ultimately simple, I guess, right? Like I said, for me, LinuxCNC has been awfully hard, but then once you get it, man, it is just as solid as a rock and really logical. And hopefully this is a little bit helpful to you. Have a nice night.